Hello everyone, I'm David and this is Xiang. Today we are going to show you our final project, Prospective Correction for Document Scanning, the basis of the Hough transfer. We found in a daily life it's very hard to get the document right on the screen when we take a photo. Our project is about improving how we can scan the document. In the market, there are many apps or software can help us scan the document. But our goal is not to copy or replicate the whole application. We're just making one part of it better. The part just fix how the document looks in the photo or image. In other words, enhance a special feature, perspective correction. But we found there are many common problems in the apps. The first, it's very hard to align the document to the camera when we're taking photos. Most of apps ask the user to fix it by the hand, but it is not so easy and accurate. The second part, the traditional method rely heavy on the contour detection. It works great when the document and the background look very different, but when they are similar, it doesn't work as well. Which works well when there are high contrast between the foreground and the background. However, this method faces limitations, especially in low contrast situations, where the contour tend to leak into the entire image. That's why the contour detection is not the best choice. We can see there a clear example. We just want to get the tag, just only the tag, but the contour leak into the background. It's not what we want. So finally, we decided to use the Hough transform. It helps us find the line in the photos. Even when the lines are not so clear, we can still find them if we set the parameters good. Finally, our goal of this project is implement automatic document scanning based on the Hough transform, enhance the feature of the perspective correction. So our first part of our project is Hough transform for future detection. We will use this transform to detect these lines, and if we see the parameter very low, weak feature can be detected. But however, it also can be a mess. We need to be very careful to find just the right line and show us the edges of the document. Our partner will show more the technical detail about our project. Welcome, Yang.
Okay, thanks, David. So from here, let's take a step back and look at our task again. The first observation is that when the camera is tilted too much, the one side of the document will be noticeably wider than the other. As a result, one side has to be stretched or squeezed a lot to restore the rectangular shape. As you may expect it, the result won't be very nice. Therefore, if the algorithm can't do well in this case anyway, let's just assume it won't happen. One implication of this assumption is that even if the document is rotated, the parallel and perpendicular relationship between its outlines are largely preserved. The second observation is that besides the outlines, the text and tables in the document also provide rich patterns of horizontal and vertical lines. It would be nice if they can be used as well. With these two observations, we may expect there will be a lot of detected lines are parallel or perpendicular to each other. Let's check our speculation. In this scatter plot of lines in polar representation, you can roughly spot a right angle between two groups of points. If this is still not noticeable enough for you, let's take a transform doubling the angle theta. The right angle is now turned into a straight line, as the shaded region highlighted. Besides better visualizing the pattern, the real trick of this transform is that it allows us to use PCA for finding the angle, and only lines are approximately in this angle are preserved. At this point, we probably still have more lines than needed to determine the outline. So how to choose among them? With the contour-based method, one would face the same problem that multiple contours can be found in the photo. Here we follow the similar idea as the baseline, that assume the outlines of the document form the largest rectangle in the image. Therefore, the distance between two parallel edges should be maximized. Here we can take the advantage that the lines are filtered by angles. As lines in a filtered group are roughly parallel, the row component of their polar representation can be directly used as a distance measurement. Basically, lines with the largest and smallest row are selected, and their intersections are calculated. The last step is to take the transform that maps the intersections to the vertices of the rectangle. Okay, too much talking now. Let's see some real examples. First one, left is a baseline using contour detection, and right is our method. As the contrast is high, the results are more or less the same. Second one, the example where we saw that the baseline failed. Below is our method, and it goes well. Now the hard one, white foreground, white background. The baseline takes the entire image as a contour, and our method still works. This one is a bit more interesting. There are a lot of lines in the document with random angles. Our result at the bottom is a bit less accurate at the corners, but it's still not bad. Okay, so here are some highlights about the new method. First, as we demonstrated, it's more resident to low contrast backgrounds. Secondly, no costly operation is involved in the algorithm, so it's equally efficient as the baseline. Finally, the contour method is either or none in the sense that as long as no closed contour is found, it fails. Our method, on the other hand, may give some inaccurate results, but the software using this method can let the user choose the best outlines from a set of candidates. This is a big advantage when the algorithm works with a user interface. And here are some future works. First, this method requires a threshold as it uses pole transform, and experiments show that it's quite sensitive to this parameter. It's not good to ask the user to set this value, so an adaptive thresholding is necessary. Secondly, the algorithm only works with flat surfaces. And if you take a picture of a book, it's very likely to be curved. It would be nice if we can correct that as well. The last one is an idea to build a more accurate filter for lines. With OCR, we can tell the region where the outline should be. This may not be very efficient though. That's all of our talk. Thank you.
Thank you.